Recording. All right, so welcome to the Silicon Valley JavaFX user group. We meet somewhat randomly whenever I'm in town. We try to meet on Wednesday evenings, 7 p.m., have interesting speakers on JavaFX, Java embedded, some sort of cool niche topic. Very happy to have Alex here tonight. We're going to talk about that in a sec. And before we get started, I just want to mention some of our wonderful sponsors which make this all possible. So Oracle, we're at Oracle headquarters here, so they provide the venue and also the tasty food. So thanks, Nicole, for helping us with that. Linode gives us hosting for our website and various other stuff. We have our videos hosted mostly on Ustream now, so Event's not doing much. But JFrog pays our meetup fees. So thanks for them. And we also give out JetBrains licenses. So at the end, we'll give a free copy of JetBrains to one of our lucky attendees.
Yeah. The person who gets that has to be able to beat me in a drag race.
Yeah, so Keith is challenging you to his new AMG.
Is this on foot or in a car?
In a car. Anybody could beat me. Right?
And then we get cool books like, oh, look, here's Kay's new book. Okay, so we have those to give away. And we also have lots of cool giveaways in the back, too. So the first thing we're going to do is do some quick introductions of folks who are in the room here. So, just say your name, maybe what sort of Java technology you're using and what company you work for. Or, whatever you feel like saying. Short, sweet.
Are we recording?
Yep.
Yep. Hi, I'm Sridhar. The most interesting thing I have to say relevant to today's topic is that I've worked with Google Web Toolkit and Swing, and I just get the impression that Java and maybe imperative programming languages in general are not well suited to graphics. So I'm hoping to be proven wrong in the next hour. Otherwise, I know a little bit of D3 and InfoVis JavaScript, and that to me seems a lot easier to do graphics with. So I anxiously await what's in the next hour.
Good, cool. Alex has a challenge now. Pass it that way.
My name is Bob Larson. I'm independent, and I will work with pretty much any Java technology that's appropriate to whatever job I'm working on at that moment.
Cool.
Hi, my name is Sriwaddi. I've been working in Java from 95, JDK 1.1 onwards.
Very
we
nice.
tried some AWT, HTML, 2Ds later, until the FX. So we're looking forward a big thing in 8, especially on the FX.
Cool. You want to say hi, Stu?
Yeah, when it comes around.
Okay.
Hi, my name is Srirang Kulkarni. I'm working with Visa headquarters here at Foster City from the last 7 years. I'm introduced to Java back in 1996, so I've been following, starting with the JDK 1.1 through all through Java 8. So we are building some rich UI applications. So we are in the process of choosing some of the vendors' components on the rich UI tools. So I'm trying to expose on JavaFX. Yeah, and this is Srirang here again. Thanks.
Cool.
Jim Trezzo. So lots of enterprise Java over the years, but now I'm doing fun stuff. So I'm focused on, not that it isn't fun, underwater robotics, and I'm looking at JavaFX kind of around instrumentation and stuff like that.
Nice.
And especially around ARMs and embedded and all that.
Cool.
Hi, my name is Andrew. Actually, I'm working as a quality assurance engineer, but I'm using Java for my personal perspectives, and I'm experimenting right now. So that's why I'm here.
Cool. Well, let's let folks in the next round.
My name is Andre. I've worked with Java very recently. I'm a developer and 3D generalist. I've worked mostly with Java Swing, and this is my first time here, and I wanted to kind of explore and see what more development is being done with 3D and 2D tools in terms of graphics, especially in the Java environment.
Cool.
Hi, I'm Gilles Desbordeaux, doing contract work mainly in project program management and Windows 8 and Windows Phone development.
Hello, I'm Thurman Adams, and I've been doing Java since the late 90s, and I work for a company called FunTech.
Hi, my name is Dixon. I used to work on performance, scalability, and reliability for middleware built on top of J2EE. And tonight I'm really curious on how Java. What can be built in terms of graphics, the graphical applications of Java.
Nice. You guys want to say hi? If you wouldn't mind, duck in the second to last row.
Okay.
Thanks.
Okay. Yeah, I'm Dragomir Popovic. Worked even for Sun for 3 years, 96 to 98. Used all kinds of Java technologies, kind of generalist. A lot of Java Swing in the meantime. Currently unemployed, so looking for some new challenges.
Awesome.
Okay.
And
last one, David Huang. I'm a Java EA developer.
all right. Well, last but not least, we skipped poor Stu here.
Yeah. Want to take it?
There you go.
All right. Hey, I'm Stuart Marks. I used to work on JavaFX back when it was 1.0, and I presented to this group a couple years ago. Haven't been here in a while. And I helped a tiny bit with Alex on some of this stuff, reviewing the code for his demo. And so I work in the JDK core libraries group at Oracle now. And so I worked a lot on Lambda. And so that's what I helped out with Alex and some of his colleagues in making sure that the Lambda stuff is used appropriately and effectively here. So we'll see how well that worked out.
All right, cool.
Just people up front here.
Yeah. Oh, yeah, we missed you guys up front.
I'll pass.
Pass. You want to say hi?
Want to introduce yourself?
Hi, I'm Tom. I've been
You have
here-
to say hi to the microphone, though.
That microphone.
Yeah. Sorry.
Yeah, hi, I'm Tom. Here to check out the 3D stuff.
Yeah. Yeah. Alex is a 3D guru, so you will learn a lot. All right. So without further ado, we have Alex. Alex wants my mic. Hold on a sec. Here, I'll put this on. I've muted it for now. Unmuted? Pop that somewhere in your pocket or something.
You want to introduce me, or?
You can self-introduce.
It's going to be a self-introduction. Okay. So I've been working with this.
You first need to say your name, because I
Yeah.
can't pronounce it.
My name is Alexander Kouznetzov, which is Russian name, which is really hard to pronounce for non-Russian speakers. And I've been working on JavaFX for many years, and my primary area was doing samples and demos. Most of them were shown at different JavaOne keynote sessions. And last year it was chess demo with 3D graphics, and yeah, thank you. So, although I do not work on JavaFX anymore, I still remember something, and I'm gonna tell you about the history of these demos, what API were used, how it was achieved using JavaFX 8. All right,
So
let's.
I'm not getting a signal from your laptop, so you either need to fix it on your end, or we'll switch to VGA.
It should be working very soon. How about this?
No. Here.
It's actually recognized the connection, I believe.
You know what?
Okay.
Okay, that's what's showing up behind you.
Okay. It's different from what I see here.
Probably want to mirror instead of.
Yeah.
There.
All right. All right, so the agenda for today is gonna basically cover three applications. It doesn't fit actually. Can you move this down or?
Yeah, I got it.
So those are MandelbrotSet, which Stuart was talking about. It is Chessboard animated on the right bottom, and this is another app that was not shown to public, which is 3D chess robot. I'm gonna talk about that later. So I'm gonna start with a more simple thing, is a MandelbrotSet sample, which is a standard Java sample. You can download the sources easily from oracle.com/Java. It is a part of Java samples. And its primary goal was to showcase parallel lambda calculations, which is why Stuart was reviewing it so hard. But at the same time, it was designed to show compelling JavaFX UI. And I'm gonna switch to it. I'm gonna run it. Oh, I don't see it running. Okay. My NetBeans is dead. Who knows what is the MandelbrotSet from the mathematical point of view? So, yeah. Do you want to describe it? Because I don't.
It has something to do with fractals.
Yeah, exactly. So yeah, actually, that's algorithm to construct fractals, and it is heavy on calculations. I don't remember exact formula, but it is recursive, and the number of recursions you go through determines the color of a pixel. So everything is being calculated on a complex for a complex value, which has a real and imaginary part. And when we plot that on the screen, so I'm gonna run it in a second. When we draw it on the screen, you get a nice picture. Is it possible to see? Do we want to shut down lights somehow? A little bit.
Okay. So it's too complicated.
All right.
I can turn more on.
Maybe it's in the back. Oh, you got something. Cool. I don't think that the colors are good still, but at least we can see something. So yeah. So what's interesting about fractals is that basically you can zoom them. You can zoom them again and again and see nice images inside of them, as long as you have enough enough resolution for your values. that you are using double values in this case, Java double values.
Can you take questions at the end or as we're talking? I wanted to ask a question.
Yeah, sure.
Hold on to-
Go ahead.
When you say enough resolution, you mean your video card?
No. Resolution for the double value, because what precision, right? Sorry. So when you zoom inside, we got a smaller and smaller area on the values range, and at some point we're gonna see destructions. So yeah, as I said, the idea was to visualize lambda calculations. So it is not very clear right now, but if you noticed, we are rendering this picture simultaneously from different positions. We have a compare button, and when I click it, it's gonna do first sequential calculation of the whole picture, and then parallel using lambdas. So that's basically the main feature of the Java 8. Is it main feature? Lambda? One of the major features that allows to do this stuff easily. Actually, this presentation is not about lambdas, and I don't even have a slide about that, but maybe I do.
When you say using lambdas, does that mean you're using multiple cores? Is that what you mean?
Yes, it is done in parallel.
Rather than by one core.
Yeah. All right. So I don't have a slide of that. But basically, we divide all the area into pixels by horizontal, by axis X, and by axis Y. And for each pixel, we run the same routine to calculate. And when we do that with lambdas, all the array of coordinates is divided and sent to different cores for calculation, to different threads. But it's...
What decides that? What decides what goes to what core?
That's the question to Stuart. But yeah, it's not, well...
There's nothing you do as a programmer to set that. It's all done for you automatically, and choices are made for you. Is that right?
Yeah. So, well, I can show you the code if you want. I don't have it on a slide, but I have it in the sources.
When was this code done, about a year ago?
Yeah, it was done last summer.
Here, just use my computer because the firewall blocks it.
Yeah, so this is the code basically. It is probably hard to see.
Is there anything in the code that decides that you can direct what core does what, or is it just all behind the scenes?
It is behind the scenes. So the code starts here. So we divide the range from 0 to height. We get an int stream, which is representing all the values from 0 to height. And then if we are in parallel mode, we execute parallel execution. Otherwise, we execute in sequential mode. And then for each value from Y stream, we do, so here we do, so basically in this particular implementation, we divide by strokes. Is it stroke? Is it row? Yeah, row by row, because that's more efficient other than creating a big amount of tasks to create a smaller number of bigger tasks. And basically then we calculate. So here is calculation. But the lambda is here. So this is lambda. Okay.
Would you write that differently if you had different numbers of cores? Say you had a machine with 4 cores versus one that had say 16 cores, would you write your program differently?
No.
Same way.
Yeah.
So the parallel is part of the Lambda library?
Yeah.
The Lambda library will,
Yeah.
So
I imagine you have some control over how it...
Oh, I should repeat the questions?
Yeah.
Okay. So I'm going to repeat your question. Can you say it again?
Right. So the question is parallel part of the Lambda library?
Is parallel part...
Mechanisms to control how the library behaves?
So, yeah, the question is... Maybe we should just pass the microphone.
I don't know the internals of that, but so what would be the difference, like if you use the
Lambda expression here? So it's just an anonymous method, right? So
Yeah.
internally it's going to be
This call here, parallel, actually indicates that we would like to have it calculated in parallel. And somewhere...
but see, if you use just stream, so then it's going to be a single core, and if you use parallel stream, is it going to automatically internally go to the multi-core or something? How does it work? Yeah.
So yeah, I don't want this to become a session about Lambda, but probably we should pass microphone to Stuart so he can comment on this.
Hi. Okay. Well, I'll be brief about this. Yeah. So there is. Oh, okay. We're gonna get the. I guess I should face the camera then, or should I face the questioner? You can watch the back of my head. All right. So yeah, there's a lot going on behind the scenes. So if you have, there's a new library in Java 8 called the Streams library, and it's not really directly related to Lambda, but it sort of is, because it's all geared around passing lambdas to stream operations. And when you have a stream, as person previously noted, you can run it sequentially or in parallel. And when you run it in parallel, what the stream does is it takes its input workload and splits it down into chunks and divides that up into separate tasks. And those tasks are run in a thread pool. In Java 7, we introduced a different kind of thread pool called the fork join pool. And so you can certainly write a parallel program that uses fork join pool by creating fork join task and recursively splitting it yourself. But what's new in Java 8 is that the streams library takes your workload, creates fork join tasks and splits them up, and then dispatches them into the fork join pool itself. So it's very convenient. And what Alexander's demonstration does is you set up the computation in such a way that it's easily divided. So basically the image processing is done on a scan line basis. And so what the code does is arranges for the workload to be split up by scan lines, and then when it's run in parallel, that is split up a number of different times and spread across as many cores as there are in the system. So all the work of splitting and joining and dividing up workload across the in different threads in the fork join pool, and from there onto different cores, is handled by the Java 8 Streams library, which then goes underneath to the Java util concurrent fork join pool library.
Yeah.
All right.
Any more questions?
Don't even ask. I'm just.
So basically, you have.
Hold on 1 second. It's a mic behind you.
I'm not sure if it's just me, but the rendering seems kind of slow.
He's running it on a crappy Windows laptop.
So it's not rendering that slow. It's calculation that's slow, because it is really heavy task to calculate. And let's see. So when we execute calc pixel, and in this case it's actually anti-aliased pixel, we are doing 9 calculations for each pixel, and each calculation is a recursive, and we create a complex value. No, this is wrong.
So using the Mandelbrot calculations was slowing it down.
Yeah. And we do this iterative multiplication of complex values. And it's up to 256, I think, iterations for each individual pixel. So 256 iterations, 9 times per pixel. And then you're going to fill the whole area, which is of the size of my screen. Well, it's not about graphics. It's about calculations in general, because graphics just visualizes what happens in Java behind the scenes.
What I mean is, I've seen another implementation, and I think this one here is like noticeably slower. A lot slower.
The point here was to actually show the difference. So it is intentionally was not optimized to the point when it would be hard to compare benefit of using sequential versus parallel. So if we choose a simpler region, maybe this region is too slow to calculate. If we take this one, you're going to see that it's easy to calculate. It takes just less than a second, right? But if you go to a particular area which is heavy to calculate, then yeah, you got the difference which is more noticeable. So it is kind of 5 times slower to do sequentially rather than parallel. So this demo is not about how to optimize Mandelbrot rendering. It's more about how to visualize what's happening if you do that it's sequentially versus parallel.
Yeah. I mean, it's, well, I think what I'm getting at, what I want to ask is, where does the difference come from, like in speed? Is it because it's parallel instead of sequential? Is it because
More cores involved.
How many threads do you have on the laptop?
I think it has four cores, and when it runs in parallel, I think it creates 16 threads in a pool.
Well, if you put up the task manager, put it on performance, it would show you the cores.
Oh yeah, sure.
Yeah, but it's 2 cores, probably that's hyper-threading, so it looks like 4.
Oh, it's hyper-threaded.
Yeah.
So let's find a heavier part. It's not that fast to capture the exact difference. But if you watch really accurate, let's see again. Yeah. It's hard to see. But you should believe that it is really happening.
Yeah, I guess if it was quad-core, 8-core, I'd be doing that.
Maybe I can run, see the performance for individual, for individual Java process. Yeah, something like this. Fortunately, it doesn't show nice 4 graphs for each core. Yeah, but you can see that like this peak of a 70, almost 80% of a CPU, it was happening while it was rendered in parallel. And when sequential was like 40% or something. All right, are we done with questions? Do you still have?
Yeah,
Can we pass the mic, please?
So you're actually doing parallels on the y-axis, but you're still doing sequential on the x-axis.
Yes, correct. This is more efficient in terms of overhead, because when you do calculations in parallel, there is an overhead because you need to divide tasks and then combine them together. And when you do too small tasks, you get too much of overhead. So this was good enough. So yeah, let's go back to the JavaFX and applications. So okay, so as I already said, the idea here was to cover, to visualize how the calculation is happening. So so we wanted to see the pixels as they were coming. We wanted to see all pixels as a reference. We wanted to have a clear difference between all the new pixels. And how should you achieve that with JavaFX? So as a main rendering surface, we use the Canvas node. Canvas node is good that it allows you to have a graphics context on it, and graphics context object allows you to do different rendering operations. Who knows JavaFX here? At least to some extent. So JavaFX is primarily it consists of different nodes. But if you would like to render something on the screen, you should either construct it from different nodes or use an image. So basically, with MandelbrotSet, there were two approaches. One is to use image with a buffer where you directly write pixels, or use a canvas, which actually has a different amount of drawing commands. And the reason why the canvas was chosen is because it allows you to do okay, so let me put it that way. So although we have a draw image command here, or we have a set pixel command here, or something like that, it does not mean that when you invoke it, it goes to the canvas image and updates it. It actually just stores the list of commands you set in a buffer, and when the next frame is being rendered, all those commands are sent to another thread where they are actually executed. So this is something that you would like to avoid. I don't know, maybe it is too technical here, but that's the trick of this app that's going on behind the scenes. So instead of directly drawing on the canvas, it was actually drawing on a writable image. So we have a writable image called off-screen, and it provides a pixel writer, and pixel writer allows you to set color for each particular pixel. So when the lambda is working, when it is rendering a pixel, each of the workers has an instance of pixel writer, and pixel writer allows them to set colors on the off-screen image. Who knows JavaFX threading model? Okay, it's only.
I tried a couple of things, but just using a couple of threads, just for GUIs, basically.
Yeah. So the main issue.
Wanted to do the work.
Yeah. So one of the main issues of JavaFX, well, not issues, but specifics of JavaFX is that it is single-threaded from user's point of view. So if you have that's another reason why the writable image is used to create this off-screen image to render it, because you cannot draw from different threads. And you should either synchronize all of them, and actually not just synchronize, but actually send the tasks to the main thread, which will kill all the parallelism. Or you should do a different trick like this one. So what happens here is that with this writable image, which is just an array of integer values, you can just set colors independently for different pixels. And when it comes to a so-called synchronization phase, so in JavaFX there are two threads, the main thread, the user thread, and the rendering thread. And at a rate of approximately 60 times per second, those two threads synchronize. And what was done on the user thread is copied to the rendering thread, and then the whole thing is rendered on the screen. So we should pass microphone down to the back.
It's muted. On the bottom, there's a switch to mute and unmute it. A little
Red one? No, not red one.
Thank you.
Can you try?
If the light is on, then it's on.
Yeah, you're good.
Do you have an indication that it works?
I can see the volume here.
So go ahead.
Oh, my question is, do you know if JavaFX has hardware acceleration support?
Yes, that's for sure. So main
GPU, right?
on GPU, yeah. So one of the main features of JavaFX comparing to what was before in Java is that all the rendering happens on the GPU, and it uses as much of the GPU rendering capabilities as possible. And actually, if it is not a compatible GPU on the system, it's going to fall back to a so-called software rendering pipeline, which is quite slow. So the point here is that when you have a good GPU, you got a good and fast graphics with JavaFX.
How do you know which is compatible? Is there a list, or do you have?
Yeah, it is listed somewhere.
If it's on the list or something?
There should be a list somewhere. I don't have.
Java, if it's probably some sort of function somewhere to say, are you fast? One of my GPUs that I can use. There's probably a function there somewhere that you can query a particular machine through software.
Yeah, there should be a way to do that. I'm not ready to answer like immediately, but
So what was the question? It's hard to hear.
Oh my.
The question was about how can you determine whether your GPU is good enough for JavaFX
In the program.
in the program.
Used or not, right?
Yeah. So.
Other than being slow and fast.
Well, there is a way. I just don't have it ready to show, but yeah. There is an easy way and there is a hard way, as usual. If you want to do that from program, you said you want to do that per program.
Yeah, if something was going to be slow, you'd want to warn the user, okay, this is not the right computer for you.
Yeah.
Well, in Java Swing, there is a graphics environment, right? You can ask, and how many screens do you have in the system?
Can you pass the mic?
That's okay. No, just.
So can I put in something? The reason why I asked the question on hardware acceleration was because it would seem to me in the Mandelbrot example that the way to parallelize it is to parallelize it, across the GPU.
It's not done on GPU. It's all on CPU.
Yeah.
Because the MandelbrotSet is showcasing how Java works on CPU. And to visualize that, we use JavaFX as a UI. It's not showing how you can do effective calculations on GPU.
Okay.
So all the math is done by the arithmetic unit in the CPU.
Yes. Yeah, so, yeah. Although it is important part of MandelbrotSet on how this is being calculated, it is not a part of this presentation. So, you want to mute it?
Don't worry about it, just pass it.
All right. So in JavaFX, when you want to do something that is being done each frame, there is an animation timer object here. So we can create an animation timer object and invoke start method on it. And it has a body, it has a method handle, which is invoked each frame. So if your application is good at speed, it would be invoked 60 times per 60 times per second. And what we do here is we use the graphics context from the canvas and draw this offline image onto this canvas. So if I switch back to the app, 60 times per second, this background image is copied onto this surface, so to say, while the background threads are updating this background image. This is how it works in terms of rendering. So, next question. Could you please pass?
Just saying for not a question. For the GPU, there's a website on JavaFX on Oracle. On Oracle, on JavaFX 2, the compatible media for that. That includes everything, CPU, GPU, software, OS,
yeah,
and everything.
of course, there is a list of supported GPUs and CPUs. But the question was how to determine that from a program. And yeah, I know the way how to do that. I just don't know how official is that. Where you basically query what pipeline is currently running. You can distinguish whether it's direct 3D or OpenGL or software. All right, so next thing here in the MandelbrotSet is to visualize navigation. So when we drag the image, we get immediate feedback, or when we zoom in or zoom out, we get immediate feedback just as on a Google Maps. So how is that achieved? So yeah, what we do is we capture current image in the beginning with a capture method, snapshot method, which saves the current image into writable image. We calculate new position after zooming and moving, and we draw it back onto the canvas. So we clear the canvas and draw this snapshot image on top. And then we execute the same routine of rendering of the whole area, because when you, for example, zoom in, it's got distorted with the zooming, so we want to get a clear picture, so everything is re-rendered at the end. All right, next slide. Yeah, another trick that was done in this app is that when you zoom the screen, change the window size, it actually keeps your current position in the MandelbrotSet, which was a little trick, nice trick to have. So how it is achieved? Who knows about JavaFX properties? So yeah, it's good to know that most people know. JavaFX, almost every object has properties. I mean, everything that can be, every field of the class that belongs to JavaFX is usually a property which you can listen to or bind to. And for the stage object, which represents window in JavaFX, there is property for X value, the same way we have property for Y value, for width and height, for the position and for the size. So we can attach listeners to all these properties to know about any movements of the window. But the trick is not just to listen that. So there are two things. First of all, we need to watch, listen to changes to 4 properties. But we want to render only once per frame because it is too heavy to render 4 times per frame or 2 times per frame, whatever. Because we have 4 properties and we can have several of the listeners invoked in a single resize operation. For example, if you maximize window, you're gonna have both X, Y, width, and height change at the same time. So we got 4 listeners invoked. And when any of the listeners invoked, we use method local to screen for the root node of the window to determine what is the position in the screen coordinates of that node. And then we remember this position. And what is again the animation timer handler, whenever we hit this next frame operation, we check whether the height and width of the window change, and if it did, then we move the content to avoid things being moved to the left top corner of the window, because by default when you resize, the whole picture would be moved to the left top corner. So that's one of the tricks here in the Mandelbrot And this is as a reminder for those who are new to JavaFX that in JavaFX everything is a property, and it is recommended, and it's a JavaFX style to bind properties instead of doing direct set method invocations. So what is happening here is that whenever the time here on top, we have two labels which show time for the operation. And to update that time, we actually use string binding shown on the slide here. So this string binding binds a long variable to a string variable, I mean property. And this is the way how this is done. So it has a bind invocation in a constructor that binds to time value, which is a long property. And then it has a compute value method in which we take this value, actual long value from this time value property, and format it the way we want to show. And then somewhere in your component, you have a text property for a label. You just use bind method to the time to string binding, this object, passing the property that represents the value you want to show. So this is just a short story about binding and the power of binding. All right, I didn't show you one more thing with this app, is that actually I went more than just using your mouse to navigate. You can actually fly from one area to another, which looks like this. And this is a very good point when you can see how deep you can dive into a MandelbrotSet. So the way this animation is done is that we are actually rendering next MandelbrotSet image based on how far the scale of our position changes. Well, let's describe a little bit in detail. So we have two animations two positions in a Mandelbrot we want to fly from one to another. And those positions are represented by a point, a complex point, which has a real and imaginary part, and a scale. Scale shows you, well, represents how close you got to that point. Like here, we are not too far from this whole picture. Let's call this scale 1. And if we go deep like that, it should be something like 100 scale or 200 scale or 1000 scale. I don't know exactly, but we can have the same point shown here, but the scale would be so bad so you cannot see any details of that place. And we can go back and see all the details of that place. So the way this animation is created is we have two positions, and first we determine a curve. I use the Bezier curve to control the way we fly from one position to another. And the main parameter that we change is actually scale, because position is just changing linearly from one to another, and the scale changes dramatically like that. And this is a tricky animation. It is done manually. In JavaFX, we have a big set of simple animations, or like extended animations that are good when you animate something on 2D surface or in 3D, but it is really hard to apply the same stuff to this particular case. So this was done manually. So we use animation timer, which is invoked each frame, and using the time from the timer, we calculate new position for each frame using the Bezier curve that we calculated and the linear change for the position. And I will show the code. Yeah. So in the end of this calculation, we got two values, real image and scale, which is represented as here. And we have 3 objects that we actually manipulate during this animation. It is canvas, where we render our new frame. It is global snapshot, which is a snapshot of something we can see if we go like this, which contains the whole picture of the MandelbrotSet. So this is our global snapshot. And we have a canvas snapshot, which represents our previous frame. So all of these objects have their position in our world, in our MandelbrotSet world. And we use these simple formulas to move them around. We just change translation and scale for each of those. And what's this? Oh, the same slide twice. Yeah, so this contains one more formula for Bezier curve, how we calculate x, where x changes from 0 to 1, representing 0 beginning point and 1 the end point of our traversal. And we watch our current scale, and when we go too far from the current scale, we start rendering our next frame. So we snapshot our current canvas and put that snapshot into this canvas snapshot object, which is image view, and we render our next frame as usual, by the fastest way possible. We don't care about anti-aliasing and whatever is there. Yeah, anti-aliasing is the only thing. And we ensure that these 3 objects are all set in a correct Z order. So by default, JavaFX 2D Z order is determined by the order in which you place nodes into the parent. So we need to ensure that the order is correct. And yeah, no anti-aliasing. Yeah, so I think, I don't know how clear this is, but that's about how this animation was created. Yeah, if there are any questions, can you pass the mic, please?
So it looks like when you move from one point to another point, it looks like it does the zoom out, and then pan, and then zoom in.
Exactly.
And that's where you have the control points. You know, you have one slope and then flat, and then another slope.
Yeah.
So the first slope, that's the zoom out, and the flat is the pan, and then the second slope is the zoom in.
Yeah.
And that S, the value S, determines when you zoom out and when you zoom in.
Yeah, actually it determines your current zoom value. So
Okay.
S is the current zoom value. And as I said, if you may say that was scale of 1000 and now we are moving back to the scale 1. So S represents that scale. How close are we to the point?
And then how do you determine the S?
We know the S value for this position, initial one. I don't remember exactly what is the value for that, but basically the way I did that is you can print it out. So you go to an interesting place. Oops. Yeah, you go to some interesting place because when you do this, you know what part of the image you show, and that determines S. And you print out that S value and real and imaginary values for that position, and then you can store it inside the program and reuse. So it's just recalling the same values shown before. I don't know if it was clear, but was it clear?
Yeah, sort of.
Clear enough?
It changes as you go along the curve, right?
Hmm?
You're scaling S out as you go up the curve and then back.
Yeah, exactly. So it goes, let's say, to 1 and then go back to the value of the next frame. And while it happens that way, we actually move our center point from one position to another, and it is just done linearly.
So it's like the Bezier curve is the arc of the camera going from one point to the other.
Yeah, Bezier curve is used for the change of the kind of distance from the Mandelbrot set, or how deep are you inside of it. All right. Any more questions on the Mandelbrot set? Because I'm gonna go to the next demo. So sources for this are available in oracle.com site somewhere with the GDK samples. You can take a look into that to understand what I'm.
The slides that you showing, are you gonna post them or these slides?
Oh, these slides.
Yeah.
Steven, what's the?
Yeah, we can post.
Yeah, we can post them. Hopefully they have nothing confidential.
I have a question, but I don't know, is this on or not?
Yeah.
It's on? Oh, okay, just a general JavaFX question, maybe too stupid for this presentation. So what might you realistically choose JavaFX to implement a particular application? Like I'm thinking you're not going to use this for browser-based applications. Like you said, Google Maps, you'd still probably stick to JavaScript because of client-side runtime limitations. I was thinking the next best thing might be Google Earth. You could realistically implement something like this there. Am I thinking along the right lines, or is there or is there something very different that this is more suitable for?
Whirlwind is
Sorry?
Is Whirlwind Java? NASA's Whirlwind?
NASA's World?
Whirlwind, or the project.
Whirlwind.
That's NASA.
Yeah, is that Java?
Yeah, I don't know.
I'm pretty sure
Do you know? Steve?
I don't know.
You can Google quickly.
What am I supposed to be Googling?
Whirlwind, NASA's whirlwind or whirlwind?
Yeah, it's like a more technical.
Whirlwind NASA.
They're asking if that's
Google
Java
Earth.
based or JavaFX based.
Yeah, so that's
James Gosling uses it.
swing based.
It's swing.
Although, well, let me borrow them. Yeah, so the Whirlwind stuff which James has shown in the past is swing based, but he has a newer version of stuff he's using for his company, which is JavaFX based. It's a JavaFX map UI. And Johan Voss is actually working on an updated version of that because when I was out in Hawaii, James gave us the source code, and Johan has been, I don't know, cleaning it up a bit, and we're going to release it to the open source.
So his question was, what is JavaFX appropriate for? And I think
It is the best desktop UI toolkit in the world. Yeah, so if you're doing anything complicated, desktop graphics, visualizations, graphs, charts, complex UIs, it's really, really good.
So maybe Gephi, for example, which is probably implemented in C++, you could presumably re-implement the
Yeah.
whole thing with JavaFX.
Yeah, and then you'd get cross-platform and a modern UI toolkit for free. Not as good, like if you're doing traditional form-based applications for the web or that sort of stuff, you're not going to get as much benefit out of JavaFX, although it can do that.
Yeah, makes sense.
But would you say JavaFX is equally good at line drawing versus image drawing?
Thank you.
Did you leave it on or off?
So would you say JavaFX would be equally good at line drawing versus the image rendering?
Yeah, you want to answer this? It has all the 2D graphics APIs for doing lines and
I didn't get the question, actually.
Yeah, so the question was more about drawing lines and shapes, and the basic JavaFX APIs are they're scalable, persistent mode graphics. You can also do immediate mode graphics using Canvas if you want to do. Is this built using?
Yeah, it is using Canvas.
Canvas, okay. Yeah,
But
so
it's
for
not
stuff like
the best example of using Canvas for sure.
Yeah, I know, but for stuff where you're doing more high performance individual pixel manipulation, you'd rather use the Canvas API, which is also part of JavaFX, but the default is persistent mode graphics where you can draw lines and shapes and manipulate them, and then it will update automatically. Okay.
Yeah, I don't know if I should talk more about JavaFX because it was not supposed to be a talk about JavaFX in general, because there is a lot of what you can say about JavaFX, what is scene graph, what is the threading model, and what you can achieve with that, all the media support, WebKit integration, and all that stuff. I probably should not go that far. It was more about specific tricks which were used in these apps, and this was 2D app. Next one is going to be 3D app. So.
Okay, hold on just a second. I'm gonna swap batteries.
Okay. Yeah, so I definitely work with 1.3. I'm not sure about 1.2 or 1.1.
Okay, when did you start using the latest JavaFX? The
Uh,
version 8, that came with version 8. When did you start using that?
maybe 2 years ago. I don't know.
That's when you switched over and you started using that exclusively?
Well, as long as the repository for development was created for JavaFX 8, I started using it. I don't remember when exactly it happened. Probably just after previous version was released, something like that.
So what kind of change did you have to make, or should you make, if you're switching to Java 8 from previous versions?
From 2.2, you mean?
Well, from Java 7, but now we have lambdas, now we have other ways of doing code. I haven't used the Java 8 yet, but I read
Can you
that you're
pass the
supposed
mic?
to. The new changes in 8 are supposed to change really the way you write code in Java now.
Yeah, so, well, when JavaFX was, like API was designed, it was initially thought in terms of lambdas. So now with lambdas, you can change parts of your code when you like have listeners or like action, well, it's still listeners. So yeah, many things can be used as lambdas, but there is no need to do that because normal way, old way also works.
Well, I understand the new way is supposed to make it more concise, simpler, easier to understand, etc.
Sometimes yes.
Assuming that you're used to it.
Yeah. C power always, right?
Yeah, we're back on.
So, what was your last question?
Well, the last question was, I was wondering, since I haven't used Java 8 yet, I understand from what I read, just as a preview of Java 8, you're supposed to, or can, change the style to be more, to flow more, and make it more concise, easier to write, etc., because you're taking more of a Ruby or a Python method of using lambdas, which is supposed to be more modern and easier to do and quicker to do.
Yeah.
With more comprehensible code without all the ceremony that's in the, traditional Java.
Yeah,
script.
I don't think that applies too much on JavaFX. I think it is in some parts of it, yes, but in general, it is as
event listeners got easier.
Event listeners.
You can use lambdas for those and kind of collapse the syntax.
Yes, Steve, I'm waiting for your book to come out for how to write JavaFX in Java 8 optimally, the way it should be written, sort of as a. You're working on that book, right?
Yeah. It's our
When's it going to be out?
version's coming out shortly, I think.
This summer?
I'm supposed to be finishing up the.
Because I'm waiting for it, actually.
Chapters right now.
Good.
But there's some things which you do differently when you're working with Java 8 APIs.
Yeah.
But I think for JavaFX, it's mainly the event handlers have changed because it's much easier to use lambda expressions to pass those in.
So you're a fan of the Java 8 changes, then?
Yeah, but I mean, if you think about it, JavaFX APIs are fairly modern because they were written for basically Java 7, and they knew lambdas was coming. So a lot of things like binding and things, they already tried to make fluent syntax and make it fit within what'll work well with the lambda style of programming.
And that was successful, you think?
Yeah.
Okay. So when's your book coming out?
It should be published, I don't know, within 4 or 5 months, I think.
Okay, late summer?
Yeah.
Actually, one area of JavaFX where there is more use of lambdas, I think it's controls section, because there are many callbacks kind of stuff involved. So that should be more concise and simpler.
Okay.
But it's not covered here. So something like table views, tree views, all these complex controls, they have used callbacks heavily. All right, should I move to the next slide, to the next demo?
Yes.
Okay, now I'm going to Chessboard animated. Okay, so let me show it first. I'm not sure it's going to run from here. Oh, it does. So this is the same JavaFX 8, but here 3D rendering is heavily showcased. So if it is responsible, yeah. So it actually, all of these are 3D meshes, and they applied, well, I will talk about this later, how this achieved, but just watch how these pieces fight each other.
Where can I get one of those?
Got chess set.
So in this app we have 3 ways to kill different pieces. We have a nice jump for the knight, and the way we can also fight is using this, what's the name of it, laser gun or something. So this is pretty much all the movements we have, and I'm gonna talk more about how this all created in JavaFX.
You have source code for that?
So let me let me go over it. So I think the original source code for the demo is not available, but most part of it are available as part of the 3D viewer project, and I'm gonna talk about that in a second. So this was a JavaOne demo for the last year, and yeah, it shows 3D support in JavaFX. To run this, we have a really, really nice set of tools in a project called 3D Viewer. So it is available as part of the OpenJFX repository. Why do I see different?
Steven's manipulating your.
What did I do?
I don't see my slide.
Oh.
How much was I missing?
It was, that slide was what was showing. Oh, this is dead.
Sorry. Have you seen any of the chessboard playing?
Yeah, the chessboard.
Okay. Okay, so yeah, so we saw this slide and I moved to this one.
Question. So what viewer did the 2D demo use?
This project?
The
Sorry?
2D, the fractal Mandelbrot.
What I did? I missed the question.
Okay, so this uses OpenFX 3D viewer.
As part of it.
Okay.
Canvas. This is canvas.
Okay, maybe. I don't fully understand that. That's fine.
Canvas is a part of the, well, tools you can use to do 2D stuff.
Okay, well, continue. Maybe I'll get it.
Okay. So yeah, where is my app? Is it running? It's not running. Why is that? Oh, it's running somewhere here. All right. So this is a 3D viewer project we have. So the main idea of the project is to give a tool to manipulate 3D objects, to visualize them in 3D. Oh, sorry, in JavaFX. So what it supports is it can load different types of files. Currently it supports Maya files, OBJ files, FXML, Max, and there was a support for DAE, which stands for Collada format. I'll open this. This file. So this file was created in Maya Autodesk software, and you can have your professional 3D designer to create your meshes for you. So we had ours to create for us this Duke model, and you can see it here, and you can see that it has all the heads at the same time. And actually, I'm currently showing you a wireframe, but it's not just a wireframe, it's a real object. And you may notice that it has a not very smooth surface, but in the demo you didn't see that, right? So, okay. What I was going to say. So here you can see the hierarchy of the meshes inside this object. So we have heads of different types of pieces. So I can turn them off to see just a king head, or just a rook head, or a queen head. And this is how our 3D object is represented in a Maya file. So with this tool you can load and visualize your object. So what this tool does is it imports Maya file into JavaFX, creating JavaFX objects for all the parts of the Maya file. So this rendering is nothing custom. It's just a plain JavaFX rendering. So you can load your object just like I did in this chessboard animated sample demo. I was loading the same files, but was showing them on a different scene.
Okay, so we have a question from online. So Carl, he's one of our JavaFX book authors. He's wondering if the importer supports Blender files.
Yeah, what formats you support?
Well, Blender I know will export into Collada.
Okay.
And he said it supported Collada, so.
So maybe
Yeah.
via Collada it will work?
So I don't know exact level of Collada support at the moment. It was a side project which included author of Collada, and I don't know how far they get. So this is all on OpenJFX, so you can contribute to it. Our goal when we created this was to support our demos. So that was pretty much what we have in this 3D viewer application, but now available open source. So
You can make it do whatever you want now.
yes.
Quick question, the formats that you import, are any of those from standard open source tools, like, some of the CAD tools?
OBJ is a generic format, so pretty much most tools are going to be able to export that.
So actually we were primarily focusing on Maya format because we had a 3D designer with Maya, and that was the easiest for us to test and support everything because it was not simple to read it. For OBJ it was something quick, so it supports just some basic stuff. For Max, I don't remember. It was also supporting some subset. So for all of these formats, some subsets are supported. And this is not a part of JavaFX. The support of different formats is OpenJFX project, which is available for contributions. And yeah, so that's the state of it. So where is my slides? Where are my slides? So what else can 3D viewer do is that it can export your 3D object. If you were successful to read it, you can then export it as fxml, which is the JavaFX format for representing JavaFX nodes and structures, which is supported by JavaFX. Or you can directly output it as a Java object and, Java source code, which would look like something like this, which basically creates, it has long arrays of your points, long arrays of your text coords, your face indexes, and this is the kind of fastest ways to load 3D objects into Java program. And this is created, you can create this using 3D viewer. Yeah, it is also, okay, so let's move on to the next thing. I'm gonna switch back to the 3D viewer as I go. So here's how the dynamic Duke, by dynamic I mean animated Duke, is loaded. So this class Maya importer is part of 3D viewer project. So we basically add a 3D viewer jar on a class path, and then we can access Maya importer class. Then we can use it to load your Maya file. Here is the Maya file, and yeah, then we get root for this, which is just a JavaFX node, and we get a timeline which holds animation for this node, all created from the Maya file. If we go to a static Duke, it's a little bit trickier, but just because we wanted our static Dukes to look even nicer, because we have so many of them. So the trick of this program is that simultaneously we have at most 2 animated Dukes on the scene, but all the static Dukes are always here, and we replace them as they are involved in movements or fights or whatever. So, okay, let's go back to this source code. So again, we use the same Maya importer, and we load our Maya file, which has no animation this time. And then we use optimizer class from the 3D viewer project. And I'll show you on the next slide what it does. But basically, it removes unnecessary constructions from your 3D objects. Can you pass the mic?
So at what point do we have a JXML file, if at all?
Which file?
Maybe I got the name.
FXML?
FXML.
Is here we are not using it. Here we are directly loading Maya file.
So when would the FXML be used in the same kind of usage like this?
Well, instead of loading Maya file, we could have saved the same models as FXML files. But there is a reason why we didn't do that, is because our exporter was not supporting animations at the moment. So yeah, it was useless. Useless step. So yeah, for the demo, we just load Maya files as they are, and we apply optimizations, and I'm gonna talk about subdivisions in the next slide. And then, yeah, we need many Dukes with different heads, so we basically use our clone method, and we specify which head we want, which color we want, and we get as many Dukes as we need. Okay. So Optimizer is a part of 3D Viewer app. It allows to eliminate duplicate points or duplicate text cores or faces with the same points used as an indexes, faces with small areas. It also removes transforms that are identity. So by default in the Maya file, each parent has the set of the transforms associated with the node which has translate, rotate around one axis, rotate in about different axes. So you're gonna have like 9 transforms, I think, at least for each node. So this class can eliminate all the transforms that are not used. So you can see here that in 154 transforms, 122 was just identity, so they were removed. And yeah, so just a way to clean up a 3D object to make it run faster by not doing stuff that is not needed. And then here comes subdivision and a polygon mesh. So what JavaFX supports in its API is triangle mesh. JavaFX 8 has only triangle mesh, and triangle mesh is shown on this picture, which is a mesh built of triangles. And this mesh is not good for doing subdivision. And here is the example of subdivision, and that is another example of subdivision. So what happens is that in your original file you have just 1, 2, 3, 4, 5, 6, 9 points, and by doing several subdivisions you can get a nice smooth surface like this or like that. And I can show you how 3D Viewer is capable of doing that. So we're gonna load our static Duke as a polygons. So yeah, so to achieve that we need a polygon mesh, and it is available as part of the 3D Viewer project. So instead of having all faces of a mesh to be triangles, it allows them to be any polygons, and then it dynamically converts them into a triangle mesh that JavaFX can render. So so let's load our Duke model.
So what you just said was the 3D Viewer converts polygon mesh into triangle mesh. Is that what I heard?
Yes,
Okay.
that's correct. So 3D Viewer converts dynamically polygon mesh into triangle mesh. So triangle mesh is something that JavaFX could render, and polygon mesh is something that you can operate in your program, but you need to convert it into triangle mesh to see to be rendered with JavaFX. So first of all, I'm gonna load this Duke as a triangle mesh, and you can see that all the faces are built of triangles. So I'm gonna I leave just the knight's hat on it. So it is all in triangles, and it's very smooth. And that's actually how the file is stored in a Maya file. So if I turn wireframe off, you can see that it is not smooth. Well, actually, I think it is. It should be smoother than that. But anyways, when I open it as a polygon mesh, you can see that now it is actually stored as a polygon mesh as in the Maya file. Oh, sorry, as a 4-point polygons. How do you call quad? Kind of rectangles, but maybe quads. Don't know. Quadrangle. Yeah, something like that. So here is the Duke with a knight's hat original, and we can do a subdivision on it, and you can see that there was a point introduced inside each of the quad something rectangular something, and there was a point introduced on each side of that, So this was original one, and this is subdivided, and you can see that it becomes smoother when you subdivide it. And also you can go further and subdivide it twice, which is extensive in terms of amount of data produced, but it is much nicer. It looks nicer, and it's nice and smooth. Yeah, so these algorithms are also supported in 3D Viewer project. So we have a subdivision mesh where you provide your original polygon mesh, and you set a subdivision level and 2 properties on how you should behave on edges, on boundaries of your polygons, like here. And you can get smoother surfaces. Can you pass the mic, please? Here's the mic. Or I can pass it. Actually, I want to get some water.
Sit down. So.
Yeah, I'm listening.
I take it that the subdivision has to be done within the modeler?
It is done inside of Java. Where did you say you? Inside the model app?
Inside the
Maya?
Whatever's doing the modeling, and then
Maya
saved, or does Java do it on the fly? JavaFX.
It's Java doing it on the fly. That's what I was showing. So this is the visualization of what's happening. So we can. So this is. You can consider this as a modeling app, but in fact, it's just a JavaFX app. And it just shows you what is possible with JavaFX and with what is built on top of it. So we have a polygon mesh that is dynamically converted into triangle mesh. This is shown here. And then having a polygon mesh, you can recalculate its points to subdivide it once or subdivide it twice. And this code is available and you can use it. And when you were looking at the demo with the fighting dukes, all the static dukes were subdivided once dukes here. These ones. And it was just done in a software. It's not in the modeling app. What you have what was done in the modeling app looks like this. So this is the model that is stored in the file, not subdivided.
Okay.
Any more questions? Can you pass the mic, please?
Sure. So the maybe it's just a point of terminology that I missed or I totally forgot. So the meshing that's being referred to, is that the same thing as tessellation? Or is tessellation just considered something down the pipeline?
Tessellation is different. Oh. So tessellation applies, for example, if you want to render a circle, 2D circle, I think it's going to be tessellated. I'm not that good at that terminology as well, but I don't think this is part of tessellation. Sorry, I don't want to confuse you. So this is done in terms of 3D object, which is built of points. We have points which are joined as faces. So in this case, we have 4 points per each face, and we have a texture coordinates associated with each point on each face, so we can draw a texture on top of it. And when it is a triangle mesh, where each face is a triangle, it can be rendered with JavaFX. And I don't know if tessellation involves in this process or not, but it can be rendered. But if you have 4 points on a face, you cannot render it with JavaFX without using behind-the-scenes converter of of this polygon mesh into triangle mesh, so which is provided by 3D Viewer project. The reason why we use polygon mesh is because it provides subdivision. It's easy to subdivide. So we have our polygon mesh and we have our subdivided mesh built on top of the triangle mesh, which is used in JavaFX.
Which is what you want in the end. Got it.
Yeah. Any more questions?
So follow up on the tessellation question. Does this mean that the subdivisions are done in the software and not in the hardware?
Yes.
Okay.
So unfortunately, current implementation of JavaFX do not have subdivision implemented on the pipeline somewhere in GPU, which is unfortunate, but that's the state of things.
Okay. I have a slightly different. A question on a slightly different topic. Do you know how texturing is done? Is it possible? Is it possible for us to write our own shaders and plug it in?
I don't think it's currently supported. I think it was considered as one of the projects for the future, but it's not. There is no API for that. What you can do is you can hack with OpenJFX and add your shaders to it, which was the way we created our previous demo, like 2 years ago or 1 year ago, I don't remember exactly. We did a demo when we actually created our own shaders. But it was not fair because consumer of JavaFX doesn't have these shaders. While currently we have everything as part of 3D Viewer project, which is available on OpenJFX. So it's not as fast as it would be as a shader, but it's still there. It's available.
Okay, thank you.
Okay, sure. Anyways, more questions? So that's subdivision and polygon mesh. Another thing that we did in software for this demo was skinning, and it is again available as part of the 3D Viewer project. And skinning is the way you can transform your 3D mesh so that it looks natural. Like you just saw all the movements of these dukes and fights between them. And to achieve that, inside of the mesh, there is some sort of a skeleton depicted here. I can probably find a better picture. Yeah. So that's the skeleton. And here is the Duke with the skeleton inside. You can see skeleton inside. And the way this technology works in 3D animation is that each point of the original mesh can be connected to four bones on the skeleton, to 4 joints on the skeleton. So, and connection to each of them has a specific weight. So when you move the joints of the skeleton, bones of the skeleton, you recalculate all your points of your mesh to, well, with the given values, with the given factors, and you get your transformed 3D mesh. So let me show you this code. So yeah, so we have a array of two-dimensional array for each point. We have for each joint we have a weight. Oh, crap. So we have 4 weights for each point, and each should be connected to one joint. Crap. I cannot pronounce that. Two-dimensional array, number of joints multiplied by number of points of the influence weights used for skinning. This is 3D animation, so it's hard to understand. But basically you provide this, your original mesh, your weights, your transforms, your skeleton, and you just move your skeleton nodes, like rotate, scale, whatever, just transform them, and you invoke update method, and you get your 3D mesh updated. That's how it is being done in the demo. And it's much easier to do it with Maya, because you don't need to care about this in code. You actually just open your animated file, and it starts moving. So you can see the Duke walking, and then it's gonna do some different moves and jumps, and you can see that actually there is a waiting on the top, and there should be a gun somewhere. So he's gonna play all the different moves, jumps, and yeah, and stuff.
This program you have running there, that's the Maya program?
No, it's 3D viewer.
Oh, that's 3D viewer.
Yeah. I don't run Maya. I don't know how to do that. I don't have it. I just have a Maya file. So the guy who did that, he sent me a nice chart when he was showing at this millisecond, the Duke starts to jump, and this millisecond it stops his jump. Or here, from this millisecond to this millisecond, it rotates from direct position to, I don't know, 15 degrees position, and all that kind of animations, walk cycle, and all that stuff. So all I had to do is just to play different parts of the timeline. Oh, here's the jump. Okay. So I don't want to go into these details actually. It looks like it is too complicated, but for someone who wants to understand how this all works, 3D viewer code is available, and I can guide you through it. But the main idea is that instead of calculating all the points each time, we actually store formulas for calculating them. So whenever we need to update, we just have for our linear formulas, we have indexes of the points we're going to use in a calculation, and we have factors that we're going to multiply. So we just go through all the points of original mesh we depend on and multiply by different factors that were pre-calculated as part of subdivision process. And yeah, here we go. We got our point for our mesh. And this is all done for each frame. And yeah, for each mesh. So what's the question?
Yeah, I don't want to interrupt you if you're in the middle of explaining, but my question is just stepping back. It's a semi-technical, semi-business question. How far away are we from being in a marketplace where Microsoft Flight Simulator or FIFA 2014 can be implemented with JavaFX? Is it that there's some technical access that is just not there yet in JavaFX, or is it merely about the gaming industry being convinced that this can do things as well as the previous generation? I don't know what that previous generation is, OpenGL or whatever.
Well, I don't think this is something I'm gonna actually cover in this presentation, but I think that there is a long history of the gaming industry, and I don't think they're going to jump onto something which is new and not that mature as other technologies. But if you are interested in that, I don't think it should not be possible to create something like Microsoft Flight Simulator. It's just a set of objects. I don't think it has any of this animation happening in it at all, because this is more about nice animations.
Right, so you're saying in theory there is the toolkit does provide you with what's necessary to implement something like that?
Well, it was not tested, but
Yeah, I mean, I think it would be. I don't see any reason why not, based on what you've told.
yeah, it may be or may not. It can be, yeah, it can support whatever you want, but you may also run into some small issue which will block your progress until it's got fixed in JavaFX, for example.
Okay.
So it's not a gaming engine in general. So you can it's more created for like visualizations, like it is being used in chemical industry to visualize molecules or whatever you want. Yeah.
Got it.
Questions on the back?
Is this
Right.
whole JavaFX, is this going to be open source? I know that there was a talk like 2 years ago it was going to be completely open, but it hasn't happened yet, I guess.
I think it is open source.
The whole?
I think so.
The JavaFX is open source.
Yeah.
Okay, just
There could be some small parts of it.
Yeah, it's all open source.
Yeah? Okay.
So the question I had, so I see these libraries you use were part of the 3D viewer to represent objects. So natively with JavaFX, so I looked at Steve's old book here, and at least at that time,
are we done?
It didn't say that you could represent 3D objects. So
I don't hear you, sorry.
Does JavaFX allow you to represent 3D objects now, or you do it with your own libraries, and it renders them?
What? I missed your question, sorry. With all
Right.
this stuff happening.
Right. So the question is, out of the box, JavaFX, does it represent 3D objects? I mean, I saw
Yeah,
you did them with your.
It represents 3D objects, so we have mesh, so basically mesh is the foundation of everything.
Yep.
The triangle mesh. You can build pretty much everything with it. Just like you saw, we are building stuff which is far beyond that, which is poly mesh and stuff. And it also has
Subdividable
some
polygons, yeah.
primitives such as boxes,
Right.
spheres, and cylinders.
Yeah, so this is all new stuff as of JavaFX 8.
Okay.
So
that's why it's not in your book,
The new version
your old
of the
book.
book is going to cover that. The current version, which covers only JavaFX 2, doesn't have the new 3D.
Okay. So I just echo the guys in front comment there.
Yeah,
Keep working on the book. Get it out.
That was the main reason we were showing 3D that much on the JavaOne, because with JavaFX 8 it became publicly available. Before that it was more of a hack or something.
But it's in the SDK now, so
Yeah.
you can just use it.
It's just, everything here is just running on a JDK 8 without any other stuff. So projector, cooling. Oh, it was just cooling.
Steve, all of this runs on the
It does, although
I think it is not turned on.
Yeah, so the question was if all this runs on the Raspberry Pi as well. So the 3D stuff works on the Raspberry Pi as well, though it has a much much lower powered GPU. So it has a GPU.
It looks like it's
but the complexity of what
overheated
you
or
can do
something.
with the Raspberry Pi GPU is much lower. So for example, the chess demo, which we ran on the Raspberry Pi for JavaOne, rather than doing the kind of animations and advanced stuff which Alex was showing. We had a simpler version which still had a 3D chessboard and 3D chess pieces, but they were just moving in 3D space rather than doing full animations because the Raspberry Pi GPU couldn't do full animated renderings at the speed. You should know about this stuff, right? So the differences between the Raspberry Pi version and the desktop version of the 3D chessboard.
So yeah, all this stuff is too heavy to run on a Raspberry Pi.
Yeah, but you guys had a simplified version of it, which ran on the Pi.
So actually I'm not showing any slides, but the source code that I was showing was as well designed for the small computers like Raspberry Pi. When you convert your Maya file into Java, it can be loaded very fast. So it is pretty much the fastest way to load a 3D object in Java is to create a Java file with it. So that way we convert it. We have the same Duke, the static one, saved as a Java file, and on Raspberry Pi we just move it around. We don't animate. We don't do subdivision or any of that stuff. So I think we should pass the mic back to the...
Yeah, it's on, just pass it.
So Raspberry Pi is cool, and there's lots of them out there, but it's being rapidly eclipsed by some pretty potent ARM processors. So the Snapdragon and NVIDIA's stuff, what would it do with the GPUs that are on those?
Well, yeah, Intel's coming out with their own sort of...
Right, Intel's got stuff as well, maybe not so low power, but faster.
So is the GPU on the Raspberry Pi compatible with Java 8, or is it on the list?
Yes, it is compatible. Oh, it starts to work. Cool. He said GPU on a Raspberry Pi?
Yeah, is it the compatible one on the list, or is it...
Yeah, so it was a project to create JavaFX for ARM, and I think it succeeded. I don't think it is fully covering everything, but it is... yeah, it mostly covers everything.
But would it take advantage of some of these higher-end GPUs, like the Qualcomm Snapdragon or NVIDIA?
For what processor?
The graphics rendering.
I don't know details. Sorry. I can ask developers.
We probably should wrap it up pretty quick before somebody comes and boots us out.
All right.
So you have 5 minutes to wrap up your talk.
Okay.
Go for it, Alex.
So, yeah, covered this. So this is I don't think it is really interesting. And this is what I've covered already. So to play this, play the whole animation when Duke walks, starts walking, then walks, fights another piece, and then stands back to the original frame. It is all covered in this, in the sequence of this object called sequence. I don't know why I called it sequence, but anyways, which holds number of frame of the animation when the part of the animation we are interested in starts. Then it holds some formulas to move the object around. So we translate it and rotate it and even scale it using linear formulas depending on time. And yeah, so all we're gonna do next is creating for the initial position, we have a sequence of one frame which holds the default pose of a Duke standing on the field, or for the for animation when the Duke captures something with laser gun, it is frames for 4000 to 4039, and we also control our opponent, and from frame 4012 to 4026 it is reducing in size from 1 to 0. It's just some code that is created as part of the demo. Maybe not optimal, but it is achieving its goals. So whenever we have a sequence object, we use our timeline that we got from the Maya loader, from the Maya file. We play it, we set rate from this sequence object. We start from the, we remember up to which frame we're gonna play it. And if we need, we show this weight on top. If it is animation that puts the weight down, and we position it. And we start the animation from this frame, which is stored in the sequence object. And then as the animation plays, we watch the current time property, which is basically a time of the animation that is currently being played. And when we pass the play to value, so when this old time is before the play to a new time is more than or equal to, when we are getting to the end of the frame, we just switch to the next element of the sequence, which is, again, start from here. So that way we can animate a sequence of start walk, then walk cycle several times, then stop walk, then open laser, and then start walk again, and etc. Yeah. Another tricky thing here is to set up lights. So JavaFX supports ambient light, and it also supports point light sources. So to get nice picture, you actually need to, I'm gonna close this app. Do I still running? Yes, I do. So this is the example of the bed lighting here. You can control, we can play with the lights here. You can change the lights in a 3D viewer as well. So you can move lights. The point here is that to get a good lighting for your 3D scene, you should attach all your lights to the camera. Well, 2 lights to the camera, so that when you rotate camera or move it around, those lights follow the camera and always highlight objects, for example, from one side. And there should be also a backlight somewhere. So I have a code that shows how this could be done in JavaFX. So we have a perspective camera that is part of this camera group. We also put lights, all the lights in the same group, so that instead of moving perspective camera, we move the whole group, the camera group, so that all the lights are moving together. And we also translate them to different positions relative to the camera. And just this rim light is done a slightly different way. So we have a camera distance property, which for us is showing how far is the object that we are looking at. And it adds a light behind that object so that it has a light coming from the back. So this is the trick, how to get a good lighting. When you do the good lighting, everything looks really good. And that was clearly seen in this demo, which was again the same demo. So here, lighting is very good. And you can see that actually there are 2 lights, one here, one somewhere here, and one light behind. So it creates a nice look of the 3D objects. Without that, you're going to have really, really sad scene.
Sorry, quick question. I don't want to take too long, but when you showed it the chessboard the first time, the lighting was not as sophisticated. What did you change? I didn't quite follow that. You said there were 2 lights then, but what did you have the first time when you showed that?
Well, actually, I just put your attention on that because lighting was exactly the same.
Oh, it was? Okay. Maybe I wasn't as impressed the second time when I saw it. But, yeah, okay.
So I show this one where we have just one light source and it looks weird, but with that demo, the lighting is the same. So there is stuff to control camera, but basically we have 2 points from 2, and we just create a transform that rotates the camera so that you can see from what point to another with the apps axis going up. I don't want to go into details here. And I don't have much about the 3D chess robot sample, but I want to run it and show how it looks like. So I found it very useful to use JavaFX as a design to quickly design your robotics ideas, because you can parent all your objects so that when you, for example, rotate this node, the whole thing is rotated. So you have easy control over the whole construction, and we were using it to actually understand how good would be our robot when we were building it. So what should be the sizes of the legs and all of that. So I don't have much about this in this demo, but this is something that could be quickly done with just plain boxes and cylinders here, and they are all just parented in a natural way. And here is an example. So we create a box, and then we create a group that represents the stuff that is attached to that box. And here is our rotation object. It has a pivot point, it has an axis of rotation, and whatever we create next, we just put inside this group. And all we need is to control rotation for this object so that the whole thing moves. As in robotics, when you have a servo which actually controls the angle at one point, you get the whole thing rotated. And then you can visualize what happens if you move it here or there, and how far can you reach and all that stuff. So I think that's it for this demo.
Okay, and your time's up.
Okay, cool.
All right, so
no Q&A then.
We had one question from Carl again. He's wondering if...
Oh, is this the one I answered?
Okay, Stuart answered it.
Yeah, so
Thanks, Stuart.
Pass the mic.
So the binaries are should be available in the demos and samples downloads of
For
JDK.
what?
Well, like the 3D viewer, right?
3 viewers there,
Yeah.
but the chess demo itself is not there.
Okay.
It's not available.
Yeah, the 3D viewer
unfortunately.
is. And I saw the Mandelbrot viewer is not there yet, but it's going to be an 8U20, right? And so I found the source for it in the OpenJFX 8U20 or 8U dev repository. So that should be an 8U20.
Maybe, yeah. It should be somewhere in the JDK samples.
Okay, cool. So let's give Alex a big round of applause.
Thank you.
Okay, so